In this chapter, we're going to be going over arithmetic sequences and series. So starting with the arithmetic sequences. So what these are, they're just linear. So keep that in mind. We'll be coming back to that in a second. Okay, so for the definition here, a sequence in which each term after the first is obtained by adding a fixed number to the previous term is called an arithmetic sequence. So this would be similar, well, exactly the same as the slope of a linear function. You're just adding this fixed number to the previous term to get the new term. The fixed number that is added is called the common difference, which we're going to denote with a D. So let's say we have a sequence 5, 9, 13, 17, 21. We know that this is an arithmetic sequence because each term after the first is obtained by continuously adding 4. So 5 plus 4 is 9, 9 plus 4 is 13, plus 4 is 17, and so on. Since the differences between each pair of terms is the same, we know that's an arithmetic sequence. So if the common difference of an arithmetic sequence is D, then that means for any positive integer n, D is going to equal a sub n plus 1 minus a sub n, which should make sense because a sub n plus 1 is just one term after a sub n. So that just means if we subtract two terms, if we subtract the term and the term right before it, we should get the common difference. So let's see an example here. Find the common difference of the sequence, -9, -7, -5, -3, -1, and so on. So what we do is we pick any two terms next to each other. Let's pick just the first two. And then we subtract the one further to the right minus the one to the left of it. And that's going to end up being -7 minus -9, and -7 minus -9 is -7 plus 9, which is +2, which should make sense because that means, as we can see, that we're just continuously adding 2 over and over again to get to the next term. And let's do another example. Write the first given terms, that should say given, the first given terms of each arithmetic sequence. So for A here, we have the first term is 7 and the common difference is -3. So we are told that A sub 1 equals 7. So we want to find the first five terms, so I guess up here it shouldn't have said given, it should have said 5. Find the first 5 terms of each arithmetic sequence. So we want a sub 1, we want a sub 2, a sub 3, a sub 4, and a sub 5. So using the common difference, since this is an arithmetic sequence, we know we're going to be adding this. So it's going to be 7 plus -3 for the second term, which is +4. And then we're going to take that 4 and we're going to add another -3, which gives us +1, and we can probably do these in our head. And then we have that 1 plus a -3, -2, and -2 plus -3 gives us -5. Okay, so just continuously adding this common difference to get the next term. And let's see the next one. The next one, we're given a sub 1 is -12. And our common difference is 5. So finding a sub 2, it's going to be -12 plus 5, which is -7. Finding a sub 3, that's going to be the -7 plus 5, which is -2. A sub 4 is -2 plus 5, +3. And for the last one here, we have that 3 plus 5, and we get +8. Okay, so pretty simple for arithmetic sequences. And for the next thing now, kind of putting this all together, is finding the nth term of an arithmetic sequence. And so in an arithmetic sequence with the first term a sub 1 and the common difference d, the nth term is given to us by a sub n equals a sub 1 plus n minus 1 times d. We could see why this is the case real quick. So if we have a sub 1, we know that that equals a sub 1. If we have a sub 2, we know that that equals a sub 1 plus the common difference for an arithmetic sequence, which is what we've been doing. If we have a sub 3, we know that it's a sub 2 plus the common difference. If we substitute a sub 1 plus d into a sub 2, then we get a sub 1 plus d. We end up getting a sub 2 plus a sub 1 plus 2d because we combine the d's. If we look for a sub 4, that's a sub 3 plus d. If we sub in for a sub 3, which we just found was a sub 1 plus 2d plus d, that gives us a sub 1 plus 3d. So we're going to keep on getting that. We're going to keep on getting, for a sub 5, a sub 1 plus 4d. And the number here is 1 less than the number here, which is why we have the n here and the n minus 1 right there. Okay, so let's do this example. Find a sub 13 and a sub n for the arithmetic sequence. We have the sequence -3, 1, 5, and 9. So let's go ahead, and we're obviously using this formula because we just wrote it down. We have a sub n equals a sub 1 plus n minus 1d. So we need a sub 1 and we need d. A sub 1 is the first term, which is -3, and d we find by just subtracting successive terms. So it's going to be, in this case, we can use 1 minus -3, and we get positive 4. So it's just how much they are, in this case, increasing for each term. So once we have these, all we have to do is fill it in. A sub n equals -3 plus n minus 1 times 4. So there is our a sub n. And we're going to simplify that in just a second. Let's go ahead and find a sub 13. And we'll find that right over here. A sub 13, we plug in a 13 into all of the n's. We get 13 minus 1 times 4 for this term over here. And we end up getting a sub 13 equals, I'm assuming that we can all just kind of do this pretty quickly. 12 times 4 is 48, minus 3, 45. So the 13th term is going to be 45. So it's definitely a lot easier than just continuously adding 4 until we get to the 45th term. So what we can do right now is actually we can simplify a sub n. We can distribute the 4. So -3 plus 4n minus 4. Combine like terms, we get 4n minus 7. So hopefully that form kind of looks familiar. That's essentially y equals mx plus b form for a linear function. So we could have simplified it first and then plugged in for 13. It would have been the same exact thing. Okay, let's do another one. Let's find a sub 18 and a sub n for the sequence with a sub 2 is 9 and a sub 3 is 15. So let's start with what we are going to be using. A sub n is a sub 1 plus n minus 1 times d. We need a sub 1 and we need d. So first, before we find a sub 1 here, we actually have to find d first. We know that a sub 3 is 15, a sub 2 is 9. So D is going to be 15 minus 9, which is 6. So now we can find a sub 1 because we know that D equals a sub 2 minus a sub 1. We can go ahead and plug in. We know D is 6, a sub 2 is 9. Solve this for a sub 1. We can add a1 to the left, subtract 6 to the right. We would get a sub 1 equals 3. Okay, and now we can go ahead and plug in. And that's going to be a sub n equals 3 plus n minus 1 times d, which is 6. So let's just go ahead and actually solve this one, or simplify it for a sub n before we plug in for a sub 18. That's going to end up being distribute the 6n minus 6, and combine like terms, that's 6n minus 3. So that's a sub n. So the question said also find a sub 18. So let's just use the simplified version this time. It looks a little bit easier. We plug in an 18, and we do 6 times 18 minus 3, and we should end up getting 105. So the 18th term in this sequence is 105. Okay, and then one more here. Suppose that an arithmetic sequence has the 8th term is negative 16 and the 16th term is negative 40, and we want to find the first term. So this one's a lot different than what we've been doing, but we're going to do it using the same techniques that we were using before. So the trick here, in order to make this shorter than it could be, is that knowing the common difference has to be added. In this case, 16 minus 8. So 8 times we have to add the common difference from 8 to 16 to get from the 8th to the 16th term. So what that means is if we start with the 8th term and we add 8 differences to them, that's going to get us to the 16th term. So A16 equals A8 plus 8D. And what we can do is actually solve this for D. We can find the common difference now because we're given the 8th and the 16th term. So let's go ahead and do that. Put find D. And we're going to use this, what we just found. So it's a lot easier than having to just keep on adding and guessing and checking. So we get negative 40 equals negative 16 plus 8D. Add 16 to both sides, we get negative 24 equals 8D. Divide both sides by 8, we get D equals, I won't circle it, we get D equals negative 3. So what we need now is a sub 1. So let's go ahead and actually do exactly the same setup that we just did. And let's use a sub 8 with it. So in order to go from a sub 1 to a sub 8, we start at a sub 1. We need to add 7 common differences to it in order to get to a sub 8, because 8 minus 1 is 7. So it's the same concept that we just did right up here. And once we have that, we can plug everything in. We know that a sub 8 is negative 16. We're looking for a sub 1. We plug in our common difference of negative 3. And we get negative 16 equals a sub 1 minus 21. We add 21 to both sides and we get a sub 1. The first term is 5. Okay, so this is just a nice shortcut method in order to do that. And for the next thing here, let's go over the graph of a sequence. Like we mentioned in the previous section, the graph of the sequence consists of just discrete points. To determine the characteristics of the graph of an arithmetic sequence, we can start by actually rewriting and adjusting the formula for the nth term, which is what we've been using. the a sub n equals a sub 1 plus n minus 1 times d. So let's go ahead and start by distributing the d, and let's kind of see what happens here. So we're going to have a sub n equals a sub 1 plus dn, I'll write it as nd, minus d. And let's rearrange this a little bit. I'm going to rewrite this as nd plus a sub 1 minus d. So a sub 1 and d are just numbers here, so I group them up. I'm going to say let's let something else equal a1 minus d. I'm going to use a c, because once again these are just numbers here, so they're just going to combine. So a sub n equals nd plus c. And if we really want to hit home what we're trying to show here, I'm going to let a sub n be written in function notation f of n, and that's going to be f of n equals nd plus c. And now it's pretty clear that this is just a linear function. So instead of f of x, it's f of n, so n would be our independent variable here, and this linear functions in y equals mx plus b form, where d is the slope. Okay, for example, let's find a formula for the nth term of a sequence a sub n shown below, and we want the domain and range of this sequence. So we know that f of n equals d times n plus c, or n d plus c. I'm just putting d first because it's the slope. So what we need to do here is we need to figure out the d, and we need to figure out the c. So we could do it the way that we did it up here, and we could say that c is a sub 1 minus d after we figure out what the d is. But let's go ahead and just use the graph and think of it as a line. So these are discrete points, but if we think of this as a line, the question essentially becomes, what is the equation of a line? So that's going to be f of n equals the slope of this line. If we go down and to the right, clearly the slope here is going to be negative because it's a decreasing line. And down and to the right, that's going to be down 0.5, and to the right 1. So the slope is 0.5 over 1, or 0.5. So that's the d value. So it's negative 0.5 times n plus c. C is the y-intercept. It's crossing the y-axis at 4. So it's actually just as easy as this. I'm going to rewrite this using a sub n instead of f of n. We have our sequence, our arithmetic sequence, negative 0.5n plus 4. Okay, and then we also want the domain and range of this sequence. I'm just going to write that down here. The domain is going to be all of the x values. So since these are discrete points, let me get rid of this line. All of the x values are just 1, 2, 3, 4, 5, 6, 5 and 6. That's it. So they're all the x values of the dots, and the range is going to be all of the y values of the dots, and that's going to be from 1, 1.5, 2, 2.5, 3, and 3.5. Okay, so there's the domain and range. They're discrete points, meaning we can actually list them out. Okay, and the last page here for arithmetic series now. So now we're doing the series, which is going to be, remember, the sum of a sequence. So the sum of the terms of an arithmetic sequence is an arithmetic series. And it's pretty easy to find the sum of the series. If the sequence or the sum of the sequence, I should say. If the sequence has a first term a sub 1 and a common difference d, the sum of the first n terms is going to be n divided by 2 times the first term plus the last term. Another way we can write it is n divided by 2 times the first term plus n minus 1 times d. And all this is using the fact that a sub n equals a sub 1 plus n minus 1 times d. So it's replacing this a sub n with that to get that one, but they're the same exact little formulas here. So the first formula is going to be used when the first and last terms are known. If the first and last are not known, then we have to use the second formula. So let's go ahead and do 2 examples here. We want to evaluate S12, which is the sum of the first 12 terms for the arithmetic sequence -9, -5, -1, 3, 7, and so on. So we could probably figure out the first and last term pretty easily by just adding the common difference, and then we can use the first formula. But let's get some practice and use the second formula. So let's go ahead and write that down. That's going to be the sum of the first, I'll just write down the generic version of it with the n. Sum of the first n terms, n over 2 times the first term plus n minus 1 times d. And we go ahead and we plug this stuff in. So we're looking for the sum of the first 12 terms. So n is 12. 12 divided by 2 times the first term, a sub 1, is -9 plus n minus 1, so that's 12 minus 1 times d. So the only thing we need here is the common difference d, which we can use the first 2 terms and subtract. -5 minus -9, that gives us d equals 4. So we go ahead and plug that in, and we just have to not mess up order of operations. 12 divided by 2 is 6, and we end up getting 2 times -9, -18. 12 minus 1 is 11, times the 4, 44. And we just do the -18 plus 44, multiply that by 6, and we should end up getting 156. So if we added up the first 12 terms of this sequence, we would get 156. Okay, and now for this last question, let's use the formula to evaluate the sum of the first 60 positive integers. So we can actually use the first equation here. We can use this one, because if we're looking for the sum of the first 60 integers, or the first 60 positive integers, then we know the first term is 1, and we know the last term is going to be 60. So we know the first and the last term. So let's go ahead and just write that down. A sub 1 is 1. A sub 60 is 60, because it's the 60th integer. And we're going to use the formula S sub n equals n over 2 times a sub 1 plus a sub n. Okay, all we have to do is plug this stuff in now, so it's going to end up being s of 60, the first 60th integers, is 60 over 2 times 1 plus 60. And we just have to simplify this. This ends up being 30 times 61, and 30 times 61 gives us 1,830. So if we add the numbers 1 plus 2 plus 3 plus 4 plus 5 all the way to 60, we end up getting 1,830. Okay, which we also saw a shortcut for this in the previous section. All right, so that's it for arithmetic sequences and series.